So you are with us now. Say something so we can see if we can hear you or not.
Okay, hang on. Okay, I can hear that.
Yeah, they say they can hear you. Can you hear them?
Well, you can talk. Hey, can you hear me? Showing up on my computer yet, so I don't know why it's not working for me right now. But it's the lesson 10 all present.
Yeah.
Okay, now it's starting. Okay, it's loaded now.
Do you want to just stay on speaker for a while? Or are you going to try to join it?
Well, I don't know if it'll let me join. Like, it's not letting me at all.
Okay. You can just stay like that, like this, if that's okay.
Okay. Yeah, I'll probably just do it like this.
Okay. So we have already done 6 and 7. They're pretty simple.
You've done 6 and 7?
Yeah.
And are you talking about for the... Okay, I know what you're talking about. Okay. So we're on number 8.
Yeah, we just barely got to number 8.
Okay.
So we were talking about what formula to put this in. Is that the long formula, like the z, or the x plus or minus z times standard deviation over n?
Yes, that's
Okay.
right. Okay.
So our x is 541, right?
Uh-huh.
Plus or minus 1.96.
Yep.
Oops.
And then our standard deviation was 32.
Uh-huh.
And then our sample size is 50.
50. So
What's the standard of 32?
What was that?
she was asking what the standard deviation is, but I think she got it.
Okay. Okay.
So, if I'm correct, I'm just going to lay out this equation really quick to make sure I'm not wrong.
Okay.
It's 541 plus or minus 1.96, and then it's 32 over 50?
The square root of 50. Yeah.
Exactly.
Yep, that's right.
Okay.
Does the plus or minus one go first? Is it minus and then plus?
Minus.
Okay.
As long as you put it in order, the lowest to the highest, it doesn't matter which one you do first.
Oh, got it. Okay. Okay, I have my answers.
Okay.
Guys do.
I have answers as well.
You guys can go ahead.
Okay. So I got 532.13301.
Mm-hmm.
And then
You want me to
500.
give 549.87.
Yeah.
Oh, good. Okay. Awesome.
Oops. Okay. I'm just writing out what I did, so because I wrote it on my paper but not on the sheet. So.
Okay.
We can go to the next one though.
Okay. So it looks like we're going to do the same thing, but change the sample size to 100.
Okay. So it's still 95%. Oh, I must have done something wrong. Oh, I didn't.
I got my answer.
All right, go for it. Do you have yours, Angela?
Not quite.
Okay.
I'm looking at the answers, though, and I'm a little bit off.
Are you off on just like the decimals?
Well, like, one of the answers is 534.73, and I got 535.84.
Oh.
So, I don't know if maybe, like, he wants us to, because I've been, like, rounding up a little bit.
Yeah, as you compute it.
Yeah, usually if you round off before you have the final answer, it will be a little bit off. But as long as it's close enough with the prep and you know that you got it right, usually if it's just a decimal, you're okay.
Okay, did you hear that, Shaylee?
Okay.
Okay.
Yeah.
Sweet.
But to have it to be most accurate, don't round until you have your final answer.
Okay.
Okay. Are we good to go to the next one, or do you guys have questions?
I feel okay with that.
Okay. How about you, Shaylee?
What did you ask?
Are you okay to go to number 10, or do you still have questions on 9?
Yeah.
Okay.
Oh, I'm good.
So 10 says, how does the margin of error for the 95% confidence interval of sample size 50 compare to the margin of error for the 95% confidence interval of sample size 100? The 95% for 50 is larger
Yes.
than the second one.
So the like error, there's a less chance for error. Because the numbers are farther apart. Am I right?
Yeah.
Maybe I'm wrong.
No, that's
Uh,
right. Because you have more people, you have more, you know more of like what it's actually going to be. You have more of a chance of being right.
Okay.
You have more to base it on.
Okay.
So when the sample size is larger, then the margin of error decreases, right?
Yes.
Okay.
Okay, so for number 11, we're going to create a 90% confidence interval for the original 50 students.
So we're just changing the Z number.
Yes. Did we use that in part A? for 90% or not?
In part 1?
Yeah, yeah. Oh, yeah, so it's 1.65, right?
Yeah, so we'll just change 1.96 to 1.65.
Okay.
And then do everything else the same, right?
Mhm.
Yes. Okay, so for the first one, I got 533.56.
Perfect. That's what I got.
Okay.
And then the second one, did you get as well?
Hold on just a second. Okay. I have an answer now.
Okay, I got 548.44.
Me too.
Okay. Sweet. Are we good to go to 12?
Yep.
Yeah.
Okay. It says, how does the margin of error for the 95% confidence interval that you computed in question 8 compare to the margin of error for the 90% confidence interval that we just did? So,
Can I ask a quick question really quick?
totally.
So for when we're doing this, the way that I do it is like the last question. I do the 32 divided by the square root of 50 first, and then I multiply that by whatever the number is, so 1.645, and then I plus and minus that total 541. Is that how you guys are doing it, or are you doing it differently?
That's how I'm doing it, because that's how it works best on my calculator, but
Same
it
here.
does take a long time.
Because I keep getting like one off. So like the answer was 533.56, and I got 534. And then it was 538, and I got 547. And this time I even like kept all of the numbers like after the decimal, and it's still getting one off. So I'm not sure why it's doing that.
What number are you using in place of x?
I'm using 1.645.
And then the other number for, like, before the plus or minus?
Is 541.
Okay. I know that on my calculator, like, to clear it all out, I have to, like, clear it. So I write the number down I get for the square root of 50, and then I clear my whole calculator, and then I do 32 divided by whatever I got, and then clear it. I don't know if that will help, or...
Okay. Maybe. We can know. That was just, I didn't know if that was happening with you guys also. But
We'll try it in the group quiz, and we'll see if it changes at all. I don't know.
yeah. I can read 12 if you want.
Okay, go for it.
How does the margin of error for 95% confidence interval that you computed in part 2 compare to the margin of error for the 90% confidence interval that you computed in part 5?
They're almost the same.
It's like the information shifted higher. Well, wait, I take that back. It's slightly larger.
In 11? Oh, in 8?
Yeah.
So does it make you less confident?
So because we have a lower confidence interval, or we have a lower confidence interval, the margin of error will be large or smaller because we don't have to be as sure. So we have a smaller amount that.
Oh, that makes sense.
You know, if we were 100% sure, then it would be everything, and then 99% it gets smaller, 90 gets smaller, kind of thing.
Okay.
Does that make sense?
Yeah.
Yeah.
Okay. So as one gets smaller, the other gets smaller, basically.
Yes.
Yes.
Okay.
Okay, number 13. Says the BYU-I professor would like to repeat the experiment, but he wants to make sure he has enough students in his sample to ensure that his margin of error is 5. How many students will need to be in his sample to ensure he has this level of accuracy for a 95% confidence interval? So N equals, what was it? It's it was the z-score and the standard deviation over m, right?
And then all of that squared.
And all of that squared?
Mm-hmm.
Yeah, it's n equals the standard deviation over n. And then squared.
Okay.
It's times by the z-score, right? Sorry.
Yeah.
You guys-
Yes. So for 95%,
It's 1.96.
and our standard deviation was 32, and m was
50. Is that
m
what
is the margin of error, right?
Yeah, so it's 5.
wait, is it the square root of, oh, it's over m, not the square root of n anymore.
Yeah, exactly.
Wait, I have that it's over the square root of n that I wrote down.
The square root of n is when we're still trying to find the margin of error. For this, it's over m. As in
Oh, because he uses the margin of error. I see.
Okay. So.
So I got an answer. You can let me know when you guys do.
Okay. I have my answer too. Are you ready, Angela?
Yep, I'm ready.
I got 157.35. Is that right?
And then we have to round up to a whole number because you can't have a partial.
Yeah, so it would be 158.
Yeah.
Mm-hmm.
And you always round up, right? No matter if it's like 0.35, you always go up.
Yeah.
When we're dealing with how many people, we always round up.
Okay, because you can't have 0.35 of a person. Got it. Sweet. Are you guys ready to do the quiz then?
Yeah.
I think so.
Let's do it.
Okay.
Okay, so 3. Are you guys ready?
Yes.
Find the margin of error for a 90% confidence interval when the standard deviation is 50 and n equals 25.
Okay.
Earlier, because I've gone through this a little bit, just to maybe be more prepared. And I went through it, and would it just be the 1.96?
I think for 90%, it's 1.65, right?
1.645.
I would do 1.645 to just
Okay.
be more
Yeah.
precise, I
Oh,
guess.
yeah, sorry. That's what I meant.
No, you're good.
So we use that, and then we plug that into the formula.
Okay.
What's
So
the
what?
formula for this?
Yeah, what's the formula? Because we don't have the mean.
So it's the same for the other one. You just don't worry about the x bar plus or minus. You just do everything after the plus or minus. So it's z star times the sigma over a square root of n.
Okay.
Wait.
Okay.
Are you guys ready?
Yeah, what did you get? I'm not sure that I did it right, so I want to know what you got.
I got, can I say what I got?
Yes.
Sorry, I didn't hear what Angela said.
Yeah,
I got 11.645.
I just got 16.45.
Shayla, can you see what you got again?
What?
Will you say what you got again, Shaylee?
I got 11.645.
All right, can we maybe walk through setting up that equation, because I got it wrong. So can we maybe
What I did,
So it's 1.645
Uh-huh.
50 divided by the square root of 25,
Uh-huh.
and that's it.
Okay.
the reason why I got a weird answer, so I did get 16.45. What I did was I added it on accident.
Oh,
And
okay.
that's the multiplier.
That would make sense.
Yeah, but I got the right one after that.
Okay.
Awesome. And Angela, are you good now?
No, I still got the wrong answer, so let me try one more thing.
Angela, 50 divided by the square root of 25 would be 50 divided by 5, so that would be 10. And then you just multiply 10 by 1.645.
Okay. All right, I got it. Thanks.
Perfect. I'll read 4. It says, which of the following statements is true? Mu is a point estimator of x bar. Sigma is an interval estimator of sigma squared. X bar is a point estimator of mu. Sigma squared is an interval estimator of x bar.
I literally have no idea.
I think it's C.
I did too, because X bar is a point estimator of mu. Yeah, that one makes sense to me. But then, yeah.
I'm pretty sure that's what it is.
Yeah, basically what this is saying is that we use the sample mean to try to estimate what the population mean is.
Okay.
Okay. Shaylee, do you want to read 5?
Yeah. Gina wants to construct a 95% confidence interval for GMAP for us. She knows the standard deviation is 113. She collects a simple random sample size of 64 and computes X bar equaling 526. Use the information for questions 5 through 8. What is the lower limit of this confidence interval? We just do the same thing but find the lower one.
I believe so.
The negative z-score?
Yeah, I think so. So subtracting 526. Or, you know what I mean.
Yeah.
And 95 is 1 point. Let's see.
9.6.
Okay.
6. Okay.
All right. I'm ready with mine when you guys are ready.
Are you ready, Angela?
Almost. Okay, go ahead.
Are you guys talking? Because I can't hear you if you are.
No, I made a mistake, so I was going back and fixing what I had. Okay. I'm ready now.
All right. You can share yours, Angela, if you'd like.
Okay, I may have done this wrong, but I got 498.315.
I got pretty close.
That's what I got.
I got 498.304.
Did you round before you got the final answer?
No, I didn't.
I didn't round, I didn't round at all in this one.
Me neither. Did you guys? But you guys both got 315.
Yeah.
I got 315.
Interesting. Okay. And then, did you guys add 526 for the next one too?
Did we what?
The next one is just the upper limit. So number 6 is.
Oh, yeah. I got that one also.
So mine's probably gonna be wrong. Let's see. But I got 553.685.
That's what I got.
Yep.
Wait, what was it? What did you get?
553.685.
Yeah, that's what I have on my calculator right now.
Okay.
So should we try doing that lower one again and see if we get a different number? Because we have 2 different numbers, so maybe we should try calculating it again really fast.
No, I think you guys are right. Because I don't know why. Let me see.
Okay.
Yeah, I got 1.5 now. I don't know what it was.
Okay.
Okay. So number 7, Angela, do you want to read it?
Sure. What would happen to the width of the confidence interval if Gina increased the sample size? So if we increase the sample size, then we're probably going to get closer to the to mu, right? So
I
the
feel like
confidence.
I
Oh,
think
it'll
it'll-
increase. Wait. What happened to the width of the confidence?
Because if we have a larger sample size, then it'll be less chance of error, so it'll decrease the width.
Yes.
Okay. All right.
Also, another way to think about it is that you'll be dividing by that larger number, and so it will be smaller as well.
Oh, that makes sense.
Okay. Okay, I'll read 8. It says, what would happen to the width of the confidence interval if Gina changed it to a 99% confidence interval? So 99% is 2.576, right?
So
Mhm.
it would increase.
Oh, yeah, you're right. We don't have to do any. I think that's right.
Yeah, because you have to be more sure, so you have to have more numbers that are included in it to be more sure.
Okay.
Not as sure, it's smaller, and then as you get more sure, it's larger.
Okay.
Okay.
Wait, so it will increase, that's right.
Yeah, so number 8 is increase.
Okay. I can read number 9.
Awesome.
Okay.
Brightbulb Light Bulb Company is planning a study to assess the average life expectancy of their light bulbs. They know the standard deviation is 400 hours. They want a 95% confidence interval with a margin error of 50 hours. What sample size do they need? So I've actually already done the rest of the problem, so we can just I'll just go along with you guys.
Oh, okay.
Wait, you said you already did the rest of them? Is that what you...
Yeah.
Okay. Perfect. Okay, so this is the one that I got messed up last time. So it's going to be Z, which is 1.96, right? Times 400 over 50 squared.
Yes.
Okay, Angela, I'm ready when you are.
Hold on just a minute. Wait, Wait, so it's 1.96 times 400?
Yes.
Yeah.
Okay, so I just got 110.8743.
I did not get that.
Uh-oh. Okay.
Yeah.
I got
I got
245.
246.
Yeah, 246.
Um,
Did you just square 50?
It might be, Angela, it might be the order that maybe you're doing it in.
Mm-hmm.
okay, what order did you do it in?
Because what I did is I took the, let me find this really quick. Okay, so I took the square root of 50,
Uh-huh.
and then
Which
you
is
divide that,
Wait, and what?
sorry.
So for this one, we don't need to do the square root.
What?
What?
To find the number, we don't need to find the square root of 50?
We do not?
No.
No.
Oh, sorry.
It's
No,
just
it's okay.
Wait, now I'm confused.
So you should have an equation that looks like 1.96 times 400
Yes.
all over 50.
And then all of that squared.
And yeah.
Oh, divided by 50 and then squared the answer.
Yes.
Yes.
Okay. Let me try that again. Wait, but you said your answer was 200 and something. Now I just got 3.959.
Do you want to go through what you're doing on your calculator with us?
Yeah, so you just said to do 1.96 times 400 divided by 50.
Yeah, so do 1.96 times 400 and press equal.
784.
And divide that by 50.
15.68.
And then square that.
Square 50. Oh, I did this. Okay, I did it backwards. I did the square root instead of squaring it.
Oh, yeah, that might make a difference.
There we go. Wait. Why? I'm sorry I can't do math tonight, you guys. I don't struggle this much.
So you should get something like 245.8624.
You said 245.86?
Yeah,
Okay.
which will just round up to 246.
Okay. Perfect. Okay.
All right. I can read the next one. Are you ready to go on, Angela?
Yep, I'm good.
Okay. So it says the mean salary of actuaries, is that what that is? Actuaries?
Yep.
Is mu equals 100,000 and the standard deviation is 36,730. You are interested to know if the mean salary for women actuaries is different from the population mean, but are not sure if it is higher or lower. You set up a hypothesis test with level of significance alpha equals 0.05, and that does not equal, and that does equal stuff. You collect a simple random sample of n equals 36 women's salaries and find that x bar equals 111,000. So 10, what is the lower limit of this 95% confidence interval?
Okay.
So standard deviation is 36,000, right?
Mm-hmm.
So over square root of 36.
Okay.
And we use x bar, right? Not mu.
Yes.
Yeah, I think it's X bar, yeah.
Okay.
Wait, I messed up. Can we maybe do the steps out loud?
Sure.
All right. What do you say?
Can we go over the steps together out loud?
Yeah.
I keep making a mistake on these, but I don't know where.
Do you want to go through them, or do you want me to go through them?
Either way.
Okay. So why don't you do it? Why don't you go the way that you're doing it?
Okay, so we take 36,730, and that's over the square root of 36, right?
Mm-hmm.
So that would give you 6,121.666.
Yes.
Yeah.
Okay. And then what was our z-score again? It was 1.96, right?
Yep.
Yes.
Okay, so I am doing what with the 6,121 and the 1.
You'll times it by 1.96.
Okay, that's what I thought. Okay. So that is 11,998.466. Or 467, yeah. Okay. And then you do what? You just find...
Then you'll add and subtract 111,000 from the number that you just said.
Okay.
To get the lower end and the higher end.
Yep.
And you round them to the nearest whole number.
Wait, now I have a really huge number that doesn't make sense. Hold on.
So, what did you get?
Am I adding an extra 0? Hold on. I just got a negative number, and I don't know why.
Did you do 111,000 minus 11,998, or did you do 11,998 minus the 111,000?
I'm not sure, but let me try it.
What was your negative number, or did you already clear it?
I cleared it.
Okay.
So I'm putting in 111,000. And I'm subtracting,
Yes.
and I'm subtracting 11,998.467.
Yes.
Oh, that's a huge number. Is that right?
Yeah. Yeah.
Okay. All right. It's 99,001.533.
Yes.
Yeah.
Okay. Thanks.
And then for 10, it says to round to the nearest whole number, so it would be 99,002, right?
Mm-hmm.
Yeah.
And then for the next one, we just have to add 111,000 instead of subtract.
Okay.
And if you want to share your answer when you have it, Angela.
So we're doing. Wait. Sorry. I don't know why I can't do this tonight.
So you'll just do 111,000
Yes.
and add the number that you got before, which was 11,998.
Yes. That's it?
Uh-huh.
Okay. 12,000 or 122,998.
Perfect. And then you just have to, we're just going to round up to 999, right?
Yeah.
Well, because it's not 0.5, you just leave it at 998.
Okay, because it's not a person, right?
Yes, it's not a person.
Okay. Nice catch.
So we're putting what? 12299?
998.
998.
Wait. So the answer that I got, so my answer for 10, I got 99,002.
Yeah.
And 99202. And for 11, I got 122,998.
Yep, that's what we got.
Perfect.
Okay.
Are you ready for number 12?
Yes.
Yeah.
I can read that if you want.
Go for it.
There are 3 requirements that need to be checked when computing a confidence interval for a mean. They are a simple random sample withdrawn from the population. X bar is normally distributed. Standard deviation is known. All of the above.
I believe that's all of the above, right?
Yep.
Yeah.
Cool.
Okay.
I submitted mine. It's loading.
Oh,
No.
Sweet. Nice job, guys.
perfect.
Okay, well, thank you, Megan. Sorry, Shayla, that it didn't work out.
If you guys have any other questions, feel free to email me or come into office hours, but I'm here to help you guys.
Okay.
Can I ask you a really quick question?
Of course.
So I was looking at the homework, and for the first one, it says that we need to, it asks for what the point of estimate is.
Mm-hmm.
So would we find that just by using what we've been doing?
So the point estimator is the sample mean.
The sample mean?
You don't have to do any math to find it. It is the sample mean.
It's just what they give you, right? It's just a mean.
Unless it's like they give you a list of numbers and then you need to calculate what the mean of all those numbers are to find your sample mean.
Okay, so it's just okay, perfect. Awesome. Well, that's my only question.
Okay.
Sweet. Well, thanks, guys. Have a good night.
You too.
Bye.
Bye.